Hello, Algebra 1 students. We're ready for section 4 of chapter 5. But first I want to just tell you that during this Thanksgiving season, I am thankful for you and thankful to be your teacher. So let's start off with a review. On that note, let's get to work. As you work through the review, please practice using set builder notation, and I will give you the answers after you pause and work these 3 problems. So pause the video. All right, here are the answers, so check your work please, and let's start talking about our new vocabulary in section 4. All right, the title of this section is Solving Compound Inequalities. And a compound inequality has 2 inequality signs. So it's a lot like a compound sentence. They are joined, compound inequalities are joined by the words and the words or. But they have special names. An intersection is a compound inequality joined by the word and. They have sets that are in common in an intersection. Or there's a union, and these have numbers that are in 2 different sets. So these are answers that are in common, where they join together by intersection with the word and. Union is where it's one or the other. It's 2 separate sets, one or the other. I have a Venn diagram at the bottom of your paper to help you to think about. Now, union, if it's in one or the other, it's going to be everything. If it's an intersection, the solution is only where the 2 overlap. And then the difference would be what is left over. So we're going to focus on the first 2 here, union and intersection. So let me just give you a list of numbers. Let me give you like 2, 4, 6, 8. There's one set. And let me give you another set, 2, 5, 7, 9. If I asked you for the intersection, what do they have in common? The intersection here is 2. That's what they have in common. They both have a 2. If I asked you for the union of the 2 sets, well, you would list 2 because it's in one or the other. You would list 4 because it's in one or the other. 5, 6, 7, 8, and 9 would all be part of the union of the 2 sets. All right, so if we keep that in mind while we solve inequalities that are compound. When you're looking for the and or the intersection, that can be found by graphing the inequalities. For example, h is greater than or equal to 3. So we'll come over to our graph and we'll find 3, and it's a closed circle. H is greater than or equal to 3. H is less than 7, so 3, 4, 5, 6, 7. It's an open circle. If we picked a different color, we'd go to the left and say it's not equal to 7, it's everything less than 7. And then if we have it as a compound, this one is a compound because it's given to us both at the same time. H is greater than or equal to 3 or less than 7. That means they want us to put them both on the same graph. Now, I wish that my 2 colors would mix truly. So it's still the same. 3 is still in blue, and h less than 7, I'm going to still do that in red. And the solution is where the 2 overlap. So I wish that they really did, but red and blue make purple. So where do they overlap? Well, that point is in common to both, and all of these points are in common to both. But when we get to 7, 7 was not included in the second one, so it's not in common to both. So 3 is in common to both. Here the red keeps going, but the blue did not. Here the blue keeps going, and it even included 7, but the red did not. So this is how you would graph h greater than or equal to 3, less than 7. This is the graph. Everything in purple is the graph of that compound inequality, the intersection of h, where it's greater than or equal to 3 or less than 7. All right, our next three examples are going to be intersections, so they should overlap. I think I will actually, for the sake of time, leave number 1 for you to work after I work number 2, and I'm going to pick it because of all the negative signs. So I need to work -3 less than x minus 2, and I need to work it as x minus 2 less than 5, because both are taking place here. So x is greater than, I'll add 2, and I get -1. And here, when I add 2 to both sides, x is greater than 7. So the solution set is x greater than -1 less than 7. And now I come over to the graph, and I noticed on number 1 they provided you 3, but you need to start practicing putting them all on 1. So somewhere down here is -1, and it's not equal to -1. X is greater than. Then somewhere up here is 7, and it's not equal to 7, and it's less than, so it's going in the opposite direction. So the solution, or the graph of the solution, are all the points in between -1 and 7, and of course not including -1 and 7. So somehow I need you to show me on your paper with your pencil. That's why I do this big squiggly marks, because I know the green would show up on the black ink, but on your paper, your pencil mark, it's hard to see. So if you'll learn how to shade it, I sure would appreciate it. All right, and now we need to take care of this intersection, where I'm just going to work each side. So add 3, y is greater than or equal to -8. Add 3, y is less than or equal to -5. So again, here's -8, 7, 6, 5, there's -5. It is equal to, so y is greater than or equal to, so it's going to go to the right. It's less than or equal to, so it's going to go to the left, and it's all the points in between. So this is the graph of y greater than or equal to -8, less than or equal to -5, and notice there's solid dots because the numbers here are included in the solution. All right, let's scroll down. All right, we're going to work a union problem where it's OR. So again, we're still solving our equations by subtracting 5 from both sides. So -2x is greater than 10. Divide by -2. Divide by negative. Be careful, there's that negative sign again. So x is less than -5, so be careful. On the other side, I have 5x greater than, when I subtract 15, it's going to be 5, and divide both sides by 5. X is greater than 1. So I'm going to jump over to the graph, and -5 will be down here somewhere. X is not, it's not included, it's not equal to, but it's less than, so it's going to the left. And then somewhere to the right of 0 is going to be +1, and it's not included, but x is greater than +1. So notice the graph goes in opposite directions. Your solution is one or the other. It will not overlap. So to write this solution in set builder notation, it'll be x such that x is less than -5 or x is greater than 1. So you will actually write the word or because you cannot write them joined together. I'm going to leave number 2 for you to try on your own. Okay, I'm going to try to work through number 3 with you fairly quickly. 4k is less than or equal to, I'm adding 7 here, so that's going to give me 32. Divide both sides by 4, and k is less than or equal to 8. Then on the other side, it's an OR statement, don't forget. I have -9k, and I'm going to subtract 12 from both sides, and that gives us 18. Divide by -9. Did you hear the sirens go off? I said divide by -9, so be careful. You need to flip your inequality and get a -2. So when we come over to our graph, we have -2 down low, and we have 8 somewhere up at the top. Notice how not particular I am about that. K is less than or equal to 8, so it's a solid dot, and we'll be going to the left, less than or equal to. We could pick a new color at -2, and k is less than or equal to -2. So it's a solid dot on -2, less than or equal to -2. Now wait a minute. Our solution is an OR solution. So it's one or the other. So it would be redundant for me to list both, since k such that k is less than or equal to 8 also satisfies less than or equal to -2. This is your solution set. You don't have to say the second one because it's already taken care of when you list k less than or equal to 8. Had this been an intersection problem, then we would have only listed where it was true for both. So stop the video and rewind. This is an OR problem. So this solution takes care of one or the other, whereas if it were an intersection problem, k such that it was less than or equal to -2 is where it's true for both. So it's an OR problem. Pay attention to whether we're talking about an intersection or a union, please. Compound inequalities are going to come to us as word problems also. So let's look at the first. A ski resort has several types of hotel rooms and several types of cabins. The hotel rooms cost at most $89 per night. So the cost of a hotel room, let's set up an inequality, X for hotel room, at most 89. So it could be less than or it could equal 89. Okay, so that's for the hotel. And the cabins, that's another choice. It's an option. The cabins cost at least $109 per night. So at least. So cabins can be greater than or equal to $109. You have options. You can either get a hotel room or you could get a cabin. So realize that this would be a union problem and not an intersection problem. So write and graph these compound inequalities. So here's how you would write those, and the graph, of course, there would be 89 below 109, and it's greater than or equal to 109, so it's going to the right, or less than or equal to 89. So you have options. If you want to stay on the low end, you can get a hotel room, but if money's not a problem, then you have lots of cabins that start at 109 and go up. I'm going to let you tackle number 2 on your own, and I'm going to save these inequalities. I'm going to fill these in, and these will be our POD. Y'all remind me in case I forget, starting class tomorrow. We'll give you some graphs and ask you to interpret those and put them in set builder notation. All right, that's all I have for today. I hope you have a great